Hi everyone, today's question is from the topic motion in a straight line in class 11. Now this question is quite popular because it is taken from the NCERT textbook. Usually this question is solved by using the concept of relative velocity. However, I wanted to solve this problem without using the concept of relative velocity because it gives you more insight. The question says two towns A and B are connected by a regular bus service with a bus leaving in either direction every T minutes. That means there are two towns A and B. Buses are moving from A to B and buses are also moving from B to A, right? And there is a gap of T minutes between buses, meaning first bus starts from town A, then after T minutes another bus will start from town A, after T minutes another bus will start. So that's what it means. Okay, now a man cycling with a speed of 20 km per hour in the direction A to B notices that a bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in the opposite direction. What is the period capital T of the bus service? So we need to find capital T. What is the period of the bus service? And with what speed, assumed constant, do buses ply on the road? Now let us assume these are the two towns A and B. Let us first concentrate on those buses which are going from A to B. Let's say the first bus starts. Now in the question they told the speed of the buses are constant. So let me assume the speed of the bus is VB. Now after this bus starts, after T minutes, the second bus should start, because according to question, after every T minutes, buses leave from the town, right? After every T minutes, buses are leaving the town. So first bus starts, then when first bus reaches here, let's assume after T minutes, the second bus starts. Then after again T minutes, this bus will reach somewhere here, right? And by that time, second bus will reach here. And third bus will be starting. Now what will be this gap? Well, this is the gap which is nothing but distance traveled by second bus from here to here. In what time? T minutes, right? So this distance can be written as speed of the bus into the time taken, which is T minutes. Similarly, this distance can be written as distance covered by bus number 1 from here to here in T minutes. So this distance also should be speed of the bus into time taken, which is T minutes, right? Now, according to question, there is a cyclist which is going this way, isn't it? Now, what is the speed of the cyclist? 20 km per hour from A to B. And they told the cyclist finds these buses are crossing him after every 18 minutes, isn't it? Now, what that means is, if I assume the first bus is crossing the cyclist now, traveling with velocity VC, let's say, velocity of cyclist. So if the first bus is crossing the cyclist now, then after 18 minutes, the second bus should be crossing the cyclist, isn't it? Because after every 18 minutes, the cyclist found these buses are crossing him. So if first bus is crossing the cyclist now, so let's assume the time now is 0. So at time 0, if the first bus is crossing the cyclist, then after 18 minutes, what should happen? The second bus should be crossing the cyclist. So now in 18 minutes, the cyclist from here must have reached somewhere here, let's assume. So this is where the cyclist is now. So this distance will be speed of cyclist into time taken. And what is the time from here to here? 18 minutes, isn't it? And by that time, who should reach here? Well, the second bus should reach here, which means the second bus must have reached here, which means this distance must be speed of the bus into time taken, which is 18 minutes, right? So I hope this diagram is clear. So they told after every 18 minutes, the buses are crossing the cyclist, right? That means if the first bus is crossing the cyclist now, then after 18 minutes, the second bus must cross the cyclist. Which means in 18 minutes, if the cyclist reached here, the second bus should reach there, right? That means if you look at the diagram, this distance, which is VB into T, plus this distance, which is VC into 18 minutes, must equal this distance, which is VB into 18, right? Now, if I take this one this side, I can take 18 common, and then I will get VB minus VC. And what was the speed of the cyclist? 20. So I can substitute here 20 kilometer per hour, right? So this speed of the cyclist was given 20 kilometer per hour. Let us call this equation 1. Now let us concentrate on buses which are coming from B to A. Well, the speed of the buses are same. So if the first bus is moving with speed VB, after T minutes, when first bus has reached here, second bus should start, isn't it? And after T minutes, when first bus will reach here, second bus will reach here, and third bus will start. And all of them have same speed, right? VB, isn't it? And this distance will be, as we have seen, VB into T. And same will be this distance. Now, remember these buses are coming this way and cyclist was going this way. Now, according to the question they told, this cyclist finds these buses are crossing him after every 6 minutes, isn't it? That means if the cyclist is right now crossing the first bus, or I can say if the first bus is crossing the cyclist now, which is going this side now, then after 6 minutes, which bus should cross the cyclist? Second bus, right? And by that time, your cyclist must have reached somewhere here, right? So this is the distance traveled by the cyclist in 6 minutes. So this will be VC into 6 minutes, right? Speed into time is distance covered. And during that time, second bus should cross the cyclist. So second bus must have reached here. Traveling what distance? Speed of the bus is VB. Time taken is 6 minutes. And if you see carefully, this plus this should be this VBT. So now the next equation will be VBT is equal to VC into 6 plus VB into 6. And if I take 6 common, VC plus VB and 6 common. And it was given VC is 20 km per hour. So this is your equation 2. So now it's quite simple. We have these two equations which we can easily solve. So if you look at the left hand sides are same, so right hand side also should be same. So 18 VB minus 20 should be 6 20 plus VB. And here 6 3s are 18, 3 into VB will be 3 VB, minus 3 into 20 will be 60, 20 plus VB. If I bring this VB this side, I will get 2 VB because 3 VB minus VB will be 2 VB. And minus 60 will go that side, plus 60 which will give you 80. So VB will be 40. And remember, this 20 was in kilometer per hour. So therefore this VB also will be in kilometer per hour. So that is the speed of the bus. Now they also wanted, remember this T. So what I can do is substitute this VB in any one of the equation. Let me substitute here. So I will get, and here also, right? So VB will be 40. T equals to 18, 40 minus 20. So it will be 40, T equals to 18 into 14 minus 20 will be 20. So you will get 20 here, will cancel 40. So 2T will be 18. Now remember this 18 was in minutes. So T will be also in minutes. Right? 18 by 2 will be 9 minutes. Right?